there, we are jumping into our little mini topic in Unit 0 of the atmosphere, the oceans, and climate. And we're going to be looking at how the atmosphere and the oceans affect the climate. And this topic here is just some basics regarding Earth's atmosphere. If we were following along in the College Board's CED, or Course and Exam Description, this topic is in Unit 4, Part 4, but I'm putting it here into our little Unit 0. So here we go with some basics regarding Earth's atmosphere. So first of all, we can break up the Earth into 4 really broad components in terms of our life support system for all life here on Earth. You've got the atmosphere, the air portion, the water portion, which is the hydrosphere, the geosphere. The prefix geo is pertaining to rocks and soil, and then the biosphere and all the living things. So those 4 spheres all interact together and allow life on Earth to exist. So we, of course, are focusing on the first one here, that being the atmosphere. So here we go. Reasons why the atmosphere is important to all life on Earth. Number 1, it provides necessary gases like oxygen and carbon dioxide. Oxygen is needed by living things in order to perform the process of cellular respiration, which is what releases energy from the food we consume. And carbon dioxide, of course, is needed for the process of photosynthesis, which plants and algae and phytoplankton are going to be doing. And clearly photosynthesis is important because that's what produces the food for everything else in the world, except for the things that live at the bottom of the ocean that rely on chemosynthesis. But anyway, so gases like carbon dioxide and oxygen are going to be found in the atmosphere. The atmosphere, I'm going to kind of lump these two together. The atmosphere is going to absorb different types of radiation. UV radiation, like in the case of the ozone layer. UV radiation is harmful to living things, causes skin cancer and mutations and things like that. Other parts of the atmosphere will absorb infrared radiation, which is what heats the surface of the planet. And obviously, speaking of heating the surface of the planet, the atmosphere helps to moderate our climate, because not only are the molecules in the atmosphere heating the atmosphere and the winds that are blowing and convection cells that are moving around the atmosphere, they will be distributing heat from the equatorial regions to the polar regions. And we'll talk about that more in another topic. And then, speaking of transporting things, in addition to heat being transported from one part of the atmosphere to another, water and nutrients can also move through the atmosphere as well. Easy enough. So as we talk about the atmosphere, I need to find a place for my picture. Let's talk about the idea of atmospheric pressure for a couple of moments here. So the gases in the atmosphere that's all around us are exerting pressure on the surface of the Earth. You don't need to write this down, but just get an overall sense of what's going on. We are literally at the bottom of an ocean full of air, and we can't really feel it, but all of those air molecules are pushing down on us, and that amount of pressure is what atmospheric pressure is, the weight of the air molecules being forced onto Earth's surface. And that's pretty much what you're seeing in this diagram here. As we get closer to the surface of the Earth, atmospheric pressure increases because you've got more of a gravitational pull. Gravity's pulling those molecules down to the surface. Got less atmospheric pressure as you go up a mountain, for example, because the molecules are spread out more. That's really all I got on this diagram. So when we talk about atmospheric pressure, we often see that there's 2 really broad types of pressure belts: high pressure and low pressure. And so that's what you can see here on this slide. I'm going to give you some characteristics of each of these 2 types of pressure systems. low atmospheric pressure. What that means is that there's not a lot of air pushing down on the surface of the Earth. So what that means is that instead of the air pushing down on the surface, the air is rising up into the atmosphere. So what would cause air to rise? What have we been talking about? Temperature. Excuse me. Hot things are less dense, therefore they rise. So warm air rises. So a place like South Florida, we tend to be under low pressure much of the time. Not all the time, but a lot of the time. Because we've got that warm air, which therefore rises off the surface. The air here in South Florida is also very moist. And the more moisture you have in the air, the less dense it is, which seems kind of backwards. Because you're like, wait, there's more water. How is it less dense? Water molecules are actually less dense than air molecules. So the more water molecules we have in the atmosphere, the lighter the air becomes and it rises. And low pressure systems tend to be cloudy. And the clouds are going to play a role in regulating the climate in an area that has a low pressure system. Again, we'll use South Florida as an example. Excuse me, I don't know why I'm coughing. The clouds will act to trap heat, usually at night more often. You know, if it's cloudy at night, all of the heat that is being released from the surface of the Earth at night, rising up, and instead of going out into space, that heat gets trapped by the clouds, kind of keeping the temperature relatively the same between daytime and nighttime. Conversely, we have high pressure systems, which have these characteristics. Usually calmer weather, not a lot of storms because there's not a lot of clouds. Blue skies, again, not a lot of clouds. Usually cooler air, not necessarily cold, but just cooler than a low pressure area. And what that means is that we've got this cool, dry air in a high pressure system. And that cool, dry air is going to sink and exert more atmospheric pressure onto the surface of the Earth. If you think about South Florida, we get high pressure systems coming through often in the winter time. Those are those days where a front comes through and it's beautiful blue skies and it's like 75 and we can open our windows, but at night it gets really chilly, depending on where you're from, because there's no clouds. Therefore, at night when the sun sets, any heat that's being radiated back from the surface of the Earth up into the atmosphere, that heat does not get trapped by the clouds and it's lost to space. So it gets pretty chilly at night when we have these high pressure systems coming through. The last bullet here about high pressure systems, that kind of goes along with what I was just saying with clouds and nighttime temperatures. Extremes in diurnal temperatures. Diurnal means daily. So places that have a lot of high pressure systems, you get a big fluctuation between the daytime temperatures and the nighttime temperatures. Daytime temperatures, it's warmer, obviously, because the sun is shining, but at night it gets significantly cooler because there's no clouds to trap that radiating heat. And you also get a lot of seasonal variation as well. So here in South Florida, if we were to say, pick one of the two that South Florida experiences most commonly, we would say that would be a low pressure system. So low atmospheric pressure means it's warm, moist air that is rising off the surface of the Earth and not exerting as much force or pressure onto the surface. Whereas a high pressure system, lots of force or pressure on the surface because the air is cooler and drier, and cool things are more dense and therefore they sink. So that's my quick little description of high and low pressure systems. Obviously, ask me if you have any questions. So the basic structure of Earth's atmosphere, we're going to talk about two things here. Talk about what is in the atmosphere, some of those gases, and then the different layers of the atmosphere. So first, the gases of the atmosphere, the composition. You can say two broad categories. The permanent gases, the ones that are not changing much on a seasonal or even a daily basis, versus the variable gases, which obviously do change. The two big permanent gases that you definitely should know are nitrogen and oxygen. Do you need to memorize these exact percentages? No. But just be aware, generally we say that the atmosphere is about 78% nitrogen and about 21% oxygen. Some of those other permanent gases, the ones that are staying, their percentages are pretty much staying at that point, include some of your noble gases like argon and neon. There's some helium, some hydrogen, also considered permanent gases. And then the variable gases, you can see a few examples there. The three that I put as variable gases are examples of greenhouse gases that trap heat next to Earth's surface. We often hear about carbon dioxide and methane being significant greenhouse gases produced by humans and industry and agriculture. And you can see their relative amounts in the atmosphere, which I realize it doesn't seem like very much, like 0.0002% is not that much methane. But it's a lot over a short amount of time when there's usually not that much methane in the atmosphere. And methane is a strong greenhouse gas that traps a lot of heat. We'll talk about that more when we talk climate change. So just wanted you to be aware of some of the gases that you can find in the atmosphere. Again, nitrogen and oxygen, the two most important. So the last thing I want to mention here in this topic are the layers of the atmosphere. So you definitely want to know the names of the layers, from the layer that's closest to the surface of the Earth, which is the troposphere, and then upward as we move away from the surface of the Earth. You can read them all. And we'll talk about kind of where one layer ends and where the next layer begins. You can come up with a little mnemonic device to help you remember those layers. I always use the mnemonic device, try some milk, then eggs, to help you remember the layers of the atmosphere. Try some milk, then eggs. Try is for tropo, and so on and so on. Out of these 5 layers, you definitely want to know about the first 2, the troposphere and the stratosphere. The troposphere is important because that's where we are. We are living here in the troposphere. The air we are breathing is in the troposphere. That's where our weather happens. The stratosphere is important because that's where the ozone layer is. And that ozone layer absorbs harmful UV radiation and protects us from UV rays that would otherwise cause skin cancer. So how do we break up each of these layers? It's based on changes in temperature as we go higher and higher into altitude, or higher and higher in altitude. You can see on the graph here how temperature changes in each layer based on altitude. Another graph showing the same thing, how temperature is changing with altitude. Temperature decreases in the troposphere, and then it increases again in the stratosphere because there's more heat being trapped, and so on and so on. So just be aware that temperature is changing with altitude, and it changes in each of the layers. So again, down here at the bottom, we're in the troposphere. Temperature decreases because the molecules move further apart. In the stratosphere, temperature increases because we've got more heat being trapped, and so on and so on. I'm just going to have to go quickly because I'm about out of time. I have a 15-minute time limit. So those are the layers of the atmosphere. Make sure you know the layers of the atmosphere and what's going on with the temperature relative in each of those layers. That's about it. If you have any questions for me, obviously you can get a hold of me. And here's a little recap for you. Pretty much what I was talking about. So that's all for now. Bye-bye.